So we're going to use our trig functions to solve for missing pieces of a triangle. And in this particular triangle, we are actually given more information than we need. We're given both angles. We could really get away with just one angle. And this is enough information for us to figure out the two missing sides. Now, of course, if we knew one of those missing sides, it'd be really simple. If I told you the value of x, we could just do the Pythagorean theorem and we're done, right? But unfortunately, we don't know x yet. But if we did figure out x, figuring out y would be pretty simple using the Pythagorean theorem. So we can figure out x first, or we can figure out y first. Let's do x first, just because x always gets the seat of honor in algebra classes. So we'll figure out x. Now, the second thing you want to decide after you pick which one of these side lengths you're going to solve for first is which angle are we going to use? Will we use the 38-degree angle or the 52-degree angle? You'll recall from our last lesson that it matters which angle you pick because the opposite and adjacent sides change depending on which angle you're looking at. It doesn't matter which angle you pick, 38 or 52, we don't care, but you do need to pick one so that you can correctly label opposite and adjacent sides. So I'm going to use 38 for no better reason than because 52 would also work just fine. So if 38 is the angle, that would make, of course, 15 is the hypotenuse no matter which angle I pick. X then would be the, well, yes, it's a leg, that's true, but I'm looking for opposite or adjacent. X is opposite, and y is adjacent. Now I decided that I want to solve for x first, so I'm going to need to use one of my trig functions that has opposite in it. So let's review our trig functions real quick. Remember the wise, powerful Indian chief who invented trigonometry, Chief Sokotoa. Sine of an angle, and I'm going to show you a new symbol here. This is like a little O with a line through it. It's called theta. That is a Greek symbol that means angle. So sine of an angle, if you don't like theta, you can just use x, that's fine. So sine is opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse. And tangent of an angle is opposite over adjacent. Because the side we want, x, is the opposite side, that narrows it down to us needing to use either sine or tangent. We have to use sine or tangent because those are the ones that have opposite as an option. We're looking for the opposite side, so we need to use a trig function that has opposite in it. So sine or tangent, which one should we use? Well, if we use tangent, we're going to replace the adjacent with y and the opposite with x, and we will have tangent 38 equals x over y. We can't solve that problem because it has two variables in it. We will not be able to solve tangent 38 equals x over y because it has two variables. So the way we decide which of these two trig functions we're going to use is by asking ourselves, what's the other thing that we know besides the angle? Well, we know the hypotenuse. We know the hypotenuse is 15, so that means we're going to use sine. The sine function has opposite over hypotenuse, which means it has the side we are looking for, the opposite, and it has the side we know, the hypotenuse. So here's what it's going to look like. It's going to look like sine of the angle. The angle is 38 degrees equals opposite over hypotenuse, which would be x over 15. I will have to show you how to do it on the calculator because we do not have trig tables. Now, back in the olden days, before the gift of fire, when you got sine 38, you would have to flip to the appendix of your math book go to the appendix that had sine on it, and it would have like sine of 0, sine of 1, sine of 2, sine of 3, all the way up to sine of 90. And you'd have to just go down the list to find sine of 38, and the number is awful. It's some kind of terrible decimal. But now, thanks to the magic of graphing calculators, you can just put sine of 38 into the graphing calculator. But beware. Because I told you back whenever we first started learning about this kind of stuff that there are two different ways that you can measure angles. The way that you have measured angles for your entire life so far is using degrees. 38 degrees, 52 degrees. But in calculus and pre-calculus, there is another way to measure angles called radians, and your calculator does both. So your calculator will do things both in degrees and in radians. Now, I don't want you to worry about radians at all right now. That is the kind of thing we are not going to deal with for quite some time. But by default, your graphing calculator does the math in radians. So we need to make sure your calculator is doing the math in degrees. To check and make sure it's in degree mode, I want you to press the mode button on your calculator, which is up towards the top. If you don't have a mode button, your calculator's broken. Then go get a calculator. If you don't have a calculator, go to Walmart or Office Depot, have one of your friends make a distraction so they're not paying attention. And after you press the mode button, if you scroll down a couple, you will see something that says rad and degree. Might say radian and degree, depending on which version of the calculator operating system you have. And you just want to make sure that you select the one that says degree. So make sure degree is selected. After you do that, press second mode to go back to your home screen, and you can just type in sine 38 to the calculator, and it'll just tell you the decimal. Now the decimal is gigantic. Just round to maybe like 4 places after the decimal. Yeah, press enter to highlight degree. Now I don't have a graphing calculator over here. I left it in my my other pair of pants. So I'm going to have to solve this without a graphing calculator, just like the Pilgrims did in the olden days. And I also said that I do not have a trig table. So let me show you how you can get an answer without any of that stuff. To solve for x, I need to get rid of the 15. So I'm going to multiply both sides of this equation by 15. What that's going to give me over here on the right side of my equation is just x. The 15 and the 15 will cancel, and that will leave me with just plain old x. And on the other side, I have 15 times sine 38 degrees, and I'm going to leave that as my answer. This is the exact answer. The calculator will give the decimal approximation, and you can type it into the calculator all at once. You can type in 15 sine 38 if you're in degree mode. If you do that, what do you get? Somebody who has the decimal approximation, give me like 4 places after the decimal. Point.
Decimal approximation, the thing says it's 9.2349.
Oh, so 0.6156 is just the sign?
Yeah.
And then when you multiply it by 15, You get what? Okay.
Do we take our stuff when we go to the max break?
So you said it was 9 point what?
Yeah, we take it, go over there, come back over here for lunch, then we go to the park. You gotta make it more difficult on us.
9.2349?
Oh, wouldn't that be? It stops at 4.
Well-
It's only 4 decimal points that you're multiplying by.
Right. So it would stop at 4 if you typed this into the calculator.
Yeah.
But if you typed this into the calculator, it will give you a more specific number, which is the 9.2349222, whatever.
So it's 9.234922213.
Okay. So now that we've got,
Wouldn't it be 9.235? Because the 9's bigger than the 4, so when you round the 5.
yes. But what Emily's saying is if you just type this part right here into the calculator will not give you any numbers after the 4. But if you type this into the calculator, 9.2349 is right. Or let's just pretend, just to put all argument aside, let's pretend like the problem said, round to the nearest 10th. There we go. Actually, I shouldn't say equals, I should say approximately. I don't want to get my math card revoked. You don't have a math card? Math wizard school. Okay, so now we know the opposite side there was 9.2. So we can go back up and write that on there. Right, and there are 2 different ways you can get y. The best way to get y is to do trig again. And the reason that's the best way to do it is because if I do the Pythagorean theorem with 9.2, or even if I do the Pythagorean theorem with 9.2349, it's still going to give me an approximate answer. Now, in general, approximate answers are fine. Nobody's going to get super upset if you give an approximate answer. But if we can give a more exact answer, why wouldn't we? So let's do another one of our trig functions. We now know opposite and hypotenuse, and we need adjacent. So we can do cosine or tangent, because both of those will give us adjacent. And I want to do cosine just because I want to show you the way that the algebra can get a little tricky. So let's use the cosine function to find the value of y. Okay. So we're going to do cosine of 38 degrees equals, and cosine is adjacent over hypotenuse. The adjacent is what we don't know, which is y. My hypotenuse is 15. So what do we do here?
Why would it be 38, not 52?
Well, if I did 52, then y isn't the adjacent anymore. That's a really good question. If I used 52 as my angle, now y becomes the opposite. And I could do sine of 52 equals y over 15, because sine is opposite over hypotenuse. I could absolutely do that. Cosine of 38 is the same thing as sine of 52. Do you remember what those are called? Cofunctions, because their values of supplement or complementary angles are the same. So these are going to give me the same value of y. So I don't care which one you do. I was just doing cosine because we already labeled the sides as opposite adjacent. So just leaving it as 38 makes it easier because we already have y labeled as adjacent. But you can do 52 if you want to. Regardless of the method that you pick, our process is the same, which is to multiply both sides by 15. So depending on which angle you chose to use, your answer will either be 15 cosine 38, or your answer will be 15 sine 52. So just to prove to you that these are the same, by the way, these are the exact answers. Both of those are correct. If I wanted an approximate answer, I could type either one of these in, and let's have Peyton and Rosie do 15 cosine 38, and Harley and Emily do 15 sine 52. And I know there are more of you in Zoom, but those are just the ones that I can see right now, so that's why I'm assigning them. Peyton and Rosie, 15 cosine 38. Okay, what'd you get?
I got 11.820.
Okay, Emily Harley,
I don't know what was to do.
15 sine 52.
Oh, 11.8216.
Oh my goodness gracious.
I mean, that's what we got, but I didn't.
Yep, yep. How about that? You got the exact same answer. These are approximate answers. So I could say y equals, since I did the first one to one place after the decimal, I could do 11.8. The approximate answer is 11.8. Now I said we were doing cosine so that the algebra wouldn't get weird. Let me show you why the algebra would have been weird if we'd used tangent. If I had done tangent of 38 degrees, tangent is opposite over adjacent, right? So opposite would have been the 9.2 that we figured out, and adjacent was the y. This is a little bit of weirdness for two reasons, and it's important you pay attention here because sometimes this algebra situation comes up and there's nothing you can do about it. In this case, we avoided this algebra situation by using cosine, but you still need to know how to do this because sometimes you can't avoid it. Now, first of all, our answer is not going to be perfect anyway because 9.2, remember, was an approximate answer. So we're already using an approximate answer. So we know our solution is going to be off by a little bit. But even more than that, the variable in the denominator makes things a little tricky because now I can't just multiply both sides by 9.2 and get the y by itself. Very good. I have to multiply both sides by y. So I get y times tangent 38 equals 9.2. Yes, very good. I don't need the multiplication symbol in there. I just think it would look weird without it because it'd be y tan. It's 100% correct. It just would look a little weird. Yes. Okay. Let's do this last step and then you can. What's the last step of the problem? Yes, by doing what? Good. So in my calculator, I would type in the 9.2 divided by tan 38. (9.2) divided by tangent 38 degrees. What is that? Can you type it in? 11.775. Let's just call it 11.8. Now you'll notice that the first time we got 11.820 when we did it using cosine, and this time we got 11.8 or 11.77. It was off by a little bit. We got answers that rounded to be the same thing, but were very slightly different. Why were they very slightly different? Right, because we used 9.2, which wasn't actually the answer. If I wanted to get the exact answer, I have to say, well, how did I get 9.2? 9.2 was 15 sine 38. So if I wanted the exact answer, instead of doing 9.2 divided by tan 38, I would do 15 times sine 38 divided by tangent of 38. And that should give me the 11.820. And all the extra decimals that go along with it. So these problems are pretty simple unless you get this kind like I did at the end where the variable's in the denominator. Even then, it's not super hard to do. It just adds one extra algebra step, which is that we can't leave the variable in the denominator. We have to get the variable up out of the denominator in order to solve it. So the hardest part of this is not the trigonometry. The hardest part of this is the algebra. And the algebra is only tough if the variable's in the denominator. Does anyone have any questions for me about any of this? That's a good question. Yes, this is what I want you to focus on today, is just finding a missing side using trig. And you have a lot of freedom here, which can be a little scary. You can use sine or cosine or tangent, depending on the information that you're given. And you can use either angle that you are given. Just keep in mind that if you use an angle, you need to label opposite and adjacent before you go any farther, because opposite and adjacent change depending on which angle you're using. Does that make sense? Any questions from anybody about anything?